So today we're going to be solving a math problem that I found on r/askmath, and it gives us a right triangle and we're supposed to find the area with this given information. So let's look at it. So we know this is a right triangle. Let's first mark that before we do anything else, and then let's read it now. So we have a perimeter equals 150 centimeters and the hypotenuse is 64 centimeters, and we're trying to find the area. So usually in normal school math you would be given two legs, side lengths, and then would be asked to find the hypotenuse side length, or a mix-up of that. But in this case, it's probably a bit weird to you because instead of that, we're given the perimeter, which is not really something which would be typically given in order to find the area. So that's why this problem is kind of special. And there are multiple ways to solve this problem, though. And one of them that a lot of people would likely use is the Pythagorean theorem. Now you're probably wondering how would that be useful? We don't even have the leg side lengths, but pretty much the reason why it's useful is because you could use other sort of identities or theorems like a plus b squared is equal to a squared plus 2ab plus b squared. And sure, you're probably wondering why this would even be useful in this whole entire problem. I mean, this method. And sure, you're probably wondering why this would be even useful in this method. But if you try the method out for yourself, you would see why this would be useful. But I'm not going to be using this method. I'm going to be using a way shorter method that a lot of people don't talk about. And that is going to be method 2, the in radius method. Now, when I say that, you're probably wondering what the heck is the in radius? And the in radius is pretty much, well, first of all, we have to talk about what an in circle is. So an in circle is the largest circle that I can fit inside this triangle. Yeah, that's a very good circle over there. And our in radius is going to be the radius of that in circle. Okay? So now that we know that, now that you know what the in radius is, let me tell you why this is even useful. It's because another formula that is used to find the area of a triangle when given the perimeter is area is equal to in radius times semi-perimeter. Now you're probably wondering what semi-perimeter is, and I'm going to explain that real quick. The semi-perimeter is just a fancy word for saying that the perimeter divided by 2, and that would just be, in our case, 150 divided by 2. That's 75 centimeters. So we can simplify that into A is equal to, I'm just going to say IR, times 75. And now you're probably wondering, okay, but how do we even find the in radius? In order to find the in radius, there's also another formula or equation, and that is in radius is equal to semi-perimeter minus hypotenuse, or C. And when we simplify that, because we already know what semi-perimeter is, because we just calculated it, it's 75. That would be IR is equal to 75 minus, and since the hypotenuse, as we can see, is 64, it's going to be 75 minus 64. So we just simplify this to IR is equal to 11. Then we substitute it back in this equation over here. So that's going to be A is equal to 75 times 11. And 75 times 11 is going to be 750 plus 75. That's 825. So, in order to be specific, the answer to this problem over here is that the area is equal to 825 centimeters squared. If you like the way I use shortcuts and methods no one really talks about in this problem, then you're probably going to like my next video a lot. Well, that's it. See you.